yahoo! Part 2 of logs. Yay! Okay, so what I'd like you guys to do is I'd like you to graph this log. It's actually a natural log, not ln, because otherwise you owe me 5 cents. I'd like you guys to graph it, then state the domain, asymptotes, intercepts, and I already told you to draw a sketch of it, okay? If you are completely confused, perhaps you could plug in some values for x. Or think of it in terms of a transformation. Okay, go ahead, put me on pause. Bye. So it's helpful for me to think about the transformations of this graph compared to the natural log of x graph. So I knew that it was going to go left 3, and then it also reflects over the y-axis, or in other words, you divide the x values by -1. So I was able to graph that. Notice that it shifted over. My domain is -infinity to 3, vertical asymptote at 3, x-intercept at 2, 0, and I showed my work of how I found that x-intercept by setting it equal to 0. That's not new news. My y-intercept is the natural log of 3. How do I get that? Plug in 0 for y. For x. And then I also made a table of values. That's a 0, in case you weren't sure. And here's what my graph looks like. Okay, so one last application for this set of notes. It says, students in a mathematics class were given an exam and then retested monthly with an equivalent exam. That would be a lot of work on the teacher's part. Woof. The average scores for the class are given by the human memory model, where T is the time in months, and T has to be between or equal to 0 and 12. So ask you 3 questions. What's the average score? What's the average score after 3 months? And then what was the average score after 11 months? So go ahead and answer those questions, and then we'll see how you did. The average score on the original exam was a 78. After 3 months, it was a 67.765. And then after 11 months, oops, I just drew a circle. That was annoying. Ew. That's kind of cool, actually. I changed my mind. Look, triangle. What do you call something that has 7 sides? Yep, you're right. Okay, anyway, after 11 months, it was 59.654. Okay? All right, so just remember what we talked about, natural logs and logarithms. The most important part is being able to convert from one form to the other. That's exponential to log and log to exponential. Good job.